Welcome to Algebra Part 2. In this video, we will do exponents in Surds. We'll start with exponents, and of course, the exponents are for grade 10, 11, and 12. But the Surds we'll do in Part 2. The Surds are only for grade 11 and grade 12. Okay, so let's get started with exponents. All right, we've got 8 exponential rules that we need to learn. And let's just go through those rules briefly. The first one is the multiplication rule. The multiplication rule states that if you are multiplying exponents with the same base, then you can add those exponents. So in this case, the base is a, that's the common base, so we could just add x and y. All right, the division rule is just the inverse of the multiplication rule, and it states that if you are dividing exponents, with the same base. In this case, a would be the base again, and then you could minus the exponent. So if you're dividing exponents with the same base, you could subtract those exponents, so x minus y. The power of a power rule states that if you've got a power inside the bracket and another exponent outside the bracket, then you need to multiply the two exponents. So the exponent inside the bracket and another exponent outside, you multiply the two exponents. All right, and the power of product rule states that if you've got an exponent outside the bracket, that exponent should be factored into both variables or a number. Okay, so if there is a number of variables inside the bracket, the exponent must be factored into all the variables or the numbers inside the bracket. The power fraction rule is very similar. The exponent outside the bracket must be factored into the numerator of the fraction, but it must also be factored into all the variables or terms in the denominator of the fraction. Okay, the zero exponent rule states that any variable or number to the power of 0 is equal to 1. All right, and the negative exponent rule states that if we wanted to write the exponent without the negative, then we can put the base and the exponent over 1. Right? If we put the base and the exponent over 1, it takes away the negative. All right, and of course, the final rule would be the fractional exponent rule. And this states that if we wanted to write an exponent that is a fraction, as we can see here, x over y is a fraction. So if we want to write it in a set form, then the numerator will become the exponent and the denominator will come before the root or the set. Okay, those are your 8 rules. Let's put them to application. Starting with question 1. Here we are simplifying using the exponential laws that we just discussed. 7 times 2 equals to 14, and if we come to x, we add the exponents, so the 1 plus the 3 will give us x to the 4. 1 plus 2 will give us 3, an exponent of 3 for y. That's the solution. Okay, for this question, we would like to change the division to a multiplication, and of course that fraction will become an inverse because division and multiplication are inverses. All right, so then we can multiply it out. 7 times 10 is 70. Right, there's an x there, only one x, and y times y is y squared. Right, multiply the bottom, the denominators. Okay. All right, so the x's will cancel and the y squared will cancel out that y squared. 70 over 10 simplifies to 7. Okay, we know the rule. If you want to take away the negative, then we put the base and the exponent over y. We'll do the same thing for the second term. Okay. 4 squared is 16. We can use 16 as the LCM. Alright, and for this numerator of 1, we ask ourselves, how many times is 8 go into 16? That would be 2 times. And then for this numerator of 1 also, we ask ourselves, how many times does 16 go into 16? Only once. Of course, 1 times 2 is 2. 1 times 1 is 1 over 16. Simplifies to 3 over 16. Okay. 1.4. Alright. Obviously, we want to write the 16 as a base and an exponent. And the way to do that is we could use 2, 3, 5, 7. So we use our prime numbers as a base. Alright, so we can actually use 2 to the power of 4. That will give us 16. 2 to the power of 4 will give us 16. And of course, we've got 3 over 4 as an exponent outside the bracket. The 4's will cancel. Okay. .5 is fairly easy. Any number or variable to the power of 0 is 1. 3 squared is 9. Alright, so if we add inside the bracket, we get 10. 10 squared is 100. Okay, so how could we write 32 as a base and with an exponent? Okay, of course, we use our prime numbers. We could use 2. Of course, 2 to the power of 5 will give us 32. Because 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So therefore, 2 to the power of 5 gives us 32. Alright, so we've written 32 as a base and an exponent. Okay, we've got x10 next to it. x10. Alright, and of course outside the bracket we've got 4 over 5. Okay, and remember there's a law which says that if there's an exponent outside the bracket, that exponent must be factored into both the number or the variable. Okay, so 2 to the 5, we factor that exponent, and also x to the 10, we must also factor that exponent. Alright, 5 and the 5 will cancel, so you have 2 to the 4, and of course 10 divided by 5 will give us 2. 2 times 4 is 8. Okay, so let's simplify this out. Okay, so we've got 2 to the 3, a to the 3, b to the 3. We're factoring the 3 into all the variables and numbers inside the bracket. Do the same thing for the second number. We get 4 to the 2, and of course a to the 6, b to the 2. In the denominator, a squared, a to the 6, b squared. Okay, we simplify this out. That's 8, a3, b3. That is 16. 4 squared is 16, and a6, b squared. Keep the denominator exactly the same. Alright, and then we can multiply it out. 8 multiplied by 16. So this is squared. So 8 multiplied by 16 will give us 128. And we come to the a and we add the exponents. 3 plus 6 is 9. Come to the b, add the exponents. Exponents of b, 3 plus 2 is 5. Come to the denominator, 8 squared is 64. and of course A6 and B2. Now we can use our division rules. 128 divided by 64 is 2, and then for division we subtract our exponents. So 9 minus 6 will give us an exponent of 3. 5 minus 2 will give us an exponent of 3 also. That's the solution. Okay. Moving right on, 1.8. Okay, so the cube root of 64 is 4. Alright, and of course the rule states that for a cube root, that you need to divide the exponent by 3. So 9 divided by 3 will give us 3. 15 divided by 3 will give us 5. The denominator, there's a square root there. The square root of 10 over 100 is 10. And of course, the square root rule is if we have the square root, we can divide the exponents by 2. So 8 divided by 2 is 4. 6 divided by 2 is 3. We could simplify this further to 2 over 5. Alright, 2 goes into 4 twice, 2 goes into 10 5 times. Alright, now how do we deal with x and y? Because the bigger exponent is at the bottom, 4 is bigger than 3, we want to keep x at the bottom, and we could subtract 4 minus 3 is obviously 1. And for y, because the bigger exponent is on top in the numerator, we keep y on top, and 5 minus 3 is 2. Okay, 1.9. Alright, before doing anything, we expand. Right. And what do you notice? You'll notice that in the numerator, those terms have 2 to the 2x in common. So if we take 2 to the 2x out as a common factor, we are left with this part. And of course, 2 to the 2x goes into 2 to the 2x once. And of course, 2 to the 2x in the numerator will cancel out the 2 to the 2x in the denominator. So we are left with 2 to the negative 2 plus 1. Simplify this further. Remember, to get rid of the negative, we put the base and the exponent over 1. Okay, of course, this is 1 over 4 plus 1. Which, of course, if we want to simplify, we can just put it over 1. Okay. And to simplify, we could use 4 as the LCM. And for this numerator, 4 goes into 4 once. Then for that numerator of 1, the denominator 1 goes into 4 times, which of course will simplify to 5 over 4. 1 times 1 is 1, and 1 times 4 is 4. 1 plus 4 is 5. And to write this as a mixed fraction, 4 goes into 5 once, and there's a remainder of 1 over 4. That's the solution. Okay, here we're solving for x. Alright, of course, which prime number would we use here? Of course, we would use the prime number of 3. We already have given a 3, so we'll keep the 3 as the prime number that we must use to solve this equation. Okay, so how do we write that fraction? Okay, of course, we do the inverse. We could just write it as 3 to the negative 2x. If we want to write it in exponential form without the fraction. And of course, if we have 3 as the base on the side, we want to have 3 as the base on the other side also. And then we need to figure out what the exponent should be. Okay, so you could do trial and error, try out different exponents. Let's try 6. 6 does not give us this number. Let's try out 8. right? 8 does not give us that number. Go up again, we try 10, and of course 10 gives us this number. So the 3 to the power of 10 will give us the number to your right. So 3 to the power of 10. And of course, not that the bases are the same, we could just equate the exponents to each other. So we get negative 2x equals to 10. And of course, if you divide both sides by negative 2, x is equal to negative 5. Okay, so that's where we say goodbye to the grade 10s. Grade 10s, remember to subscribe and like this video if you haven't done so already. The next part is only for grade 11 and 12. Surds, okay, so this is a very important rule when we're dealing with surds. The number inside the square root, we want to break it into two numbers. And we want to break the number inside the root into a number that can be square rooted and a prime number. All right. If we cannot break it into a number that can be square rooted and a prime number, we can then break it into two prime numbers. Okay. Of course, we know our prime numbers are 2, 3, 7, 11, and so forth. Okay. So let's look at 75 as an example. To write 75 inside 4 means we want to break the 75 into two numbers. A number that can be square rooted, of course, 25 can be square rooted, and a prime number of 3. 25 times 3 will give you 75. And of course, the square root of 25 is 5, and you are left with root 3. Okay, let's put this to application. All right, so we're simplifying. Okay, and of course, let's we want to break 48 into two numbers, and 75 the same. That is already a prime number, so we can leave it like that. All right, what two numbers would give us 48? One number can be square rooted, and the other number is a prime number. Those numbers are 16 and 3. Okay, 16 times 3, okay, excuse me, 16 times 3 will give you 48. Okay, of course 16 can be square rooted, and we already know that 75 could be broken into 25 times 3. All right, the square root of 16 is 4, and of course don't forget the root 3. The square root of 25 is 5, and don't forget the root 3. Okay, and as you can see, all three terms have root 3 in common, so we can add the coefficients. So that would be 4 plus 5, which is 9, and 9 minus 1 is 8 root 3. Okay, another example, 2.2. Okay, we've got 3. How do we break 18 into two numbers? A number that can be square rooted is 9 times the prime number of 2. And of course the side 25 times 2. Okay. What number can be square rooted and multiplied by which prime number will give us 72? This is of course 36 times 2. All right, if we simplify this further, we've got 3. Okay, the square root of 9 is of course 3. Don't forget the root 2. Square root of 25 is 5. Don't forget the root 2. Okay, then we have 2. What's the square root of 36? 6. Don't forget the root 2. And of course, if we simplify further, 3 times 3 is 9. Root 2 minus 5 root 2. 2 times 6 is 12 and root 2. 9 minus 5 is 4 and root 2. And at the bottom we've got 12 and root 2. Of course, root 2 will cancel out with root 2. You're left with 4 over 12, which simplifies to 1 over 3. 4 goes into 4 once, 4 goes into 12 3 times. Okay, let's go further. Of course, we'll simplify and through simplification prove that the right hand side is equal to the left hand side. Okay, let's look into that. How do we break 8? We can break 8 into 4 times 2. Remember, 4 can be square rooted and 2 is a prime number. That's already in simplified form. 4 times 3 will give us the 12. Okay, of course, this is the left hand side. Okay, this is the left hand side. All right, so at the bottom, we can use 16 times 2 minus 3 and root 3, and 27 could be broken into 9 times 3. Okay, if we go further, the square root of 4 is 2. Don't forget the root 2 minus root 3. The square root of 4 is again 2. Don't forget the root 3. Go to the denominator. The square root of 16 is 4. Don't forget the root 2. That is already in simplified form. Of course, the square root of 9 is 3. Don't forget the root 3. And then now we can look out for common factors. Of course, these two terms in the numerator are common factors. They both have root 3. So if we simplify those two terms, negative 1 and negative 2 will give you negative 3 root 3. Okay, and in the denominator, where are the common terms? These two terms are common terms. Why? Because they both have a root 3. So how do we simplify those two terms? Of course, the first term is doesn't have like term, so negative 3 minus 3 is negative 6 and root 3. Okay, if you look at the denominator, you'll see that 2 can go into 4 and into 6. So we can actually take 2 out as a common factor. Right, we leave the numerator the same. And if we take 2 out as a common factor, what do we have? 2 goes into 4 twice. Don't forget the root 2. And 2 goes into 6 3 times. Don't forget the root 3. And what you will notice is that the part in brackets is exactly the same as the numerator. Okay, so though they will cancel, and what you're left with is half. Okay, and as you can see, we have proven that the left hand side is equal to the right hand side because the right hand side is half. So we have proven that the left hand side is equal to the right hand side. Okay, let's go further. All right, so for question 4, we're solving for x. Okay, and what we want for 4.1 is to leave the part with the root on its own. So we want this part on its own. So we'll take the x to the other side of the equation. And once we have this situation, we can of course square both sides in order to cancel out the square root. Remember, the square root and the square are inverses. So 2 squared is 4. And of course, the square root will be cancelled by the square. And you'll be left with x minus 1. Okay, this we can expand. Okay, for clarity, let's just expand it and then simplify it. Of course, this is 4x minus 4. All right, this is 16, negative 4x. Of course, for simplifying binomials, and please look out for part 1 if you haven't seen part 1 already. Okay, so that would be x squared. And of course, those would be like terms. So then what we have is 16 negative 8x plus x squared. And of course, if we bring whatever is on the left to the right, we have negative 4x plus 4. Then we'll have 0. And again, we've got like terms. Okay. So what we have, if we just take whatever is on the left hand side to the right. We're going to have x squared. Negative 8, negative 4 will give us negative 12 x. So we've simplified the like terms, and of course 16 plus 4 will give us 20. And then to simplify this further, we're looking for two numbers. Those numbers will give us 20 if we multiply them, but they will give us 12 if we add them. And of course those numbers would be 2 and 10, right? Because 2 plus 10 is 12, but 2 times 10 is 20. Alright, therefore our solution will be x is equal to 2 or x is equal to 10. Okay, those are our two solutions. Okay, remember we're still solving for x, and of course what we want in this case would be to leave the x on the left on its own, and we could take the 12 to the other side of the equation, and then we could divide both sides by 3. Okay, we'll cancel. Of course this is 4. And alright, so remember we're solving x. So how do we get rid of that fraction there? Okay, we of course use the inverse of that fraction. And what's the inverse of 2 over 3? 3 over 2. And we do the same thing on the right. So, alright, and what we're left with now is x on the left. And use your calculator to check. 4 to the power of 3 over 2 gives you 8. Alright, so therefore our solution is 8. Alright, and of course if the question in the test or exam had asked you to do this without the calculator, then you could have expanded further to say, okay, 2 to the power of 2, and outside the bracket I have 3 to the 2, so the 2's will cancel, and I'm left with 2 to the 3, which of course is 8. Okay, of course you would have to do it that way if the question in the exam specifies that you are not allowed to use a calculator. This is the way to get to the 8. Okay, which is of course the same solution you get with the calculator. Alright, moving on. Alright, this is the final question. This is tricky. Of course, if you remember in part 1, we did look at how to factorize trinomials, and this is a trinomial. Okay, so if we should bring the negative 20 over to this side, alright, you'll see that this is a trinomial, except the exponents are now fractions. Alright, and of course we know that, that should be 1 over 3. Okay, we know that 1 over 3 plus 1 over 3 will give you 2 over 3. Okay, so we can factorize this into two brackets with an exponent of 1 over 3, because together they're going to give us that 2 over 3. So we have x 1 to the over 3 and x 1 over 3, and of course if we add those we get this, which is the exponent of the first term. Okay, now we're looking for two numbers added. They give us 9, and multiply they give us 20. Those numbers are 4 and 5, right? 4 and 5. Okay, 4 and 5. All right, and how do we know that? We know that because 4 plus 5 is 9, and 4 times 5 is 20. Okay, so then we can factorize this further. Okay, or is equal to -5. And of course, to get the x, we use the inverse of 1 over 3, which is 3 over 1. Okay, let's do it both sides. 3 over 1. And of course, it would be the same inverse here. The inverse is 3 over 1. Over there, we also have 3 over 1. Okay. And of course, if you are using the inverse, those values will cancel. So x is equal to, let's just check, the value of -4 to the power of 3 over 1. It's just -64. Okay, just -64 there. And on that side, of course, we've used the inverse to cancel out 1 over 3. Okay, so if we go -5 this time, -5 to the power of 3 will give us -125. So those would be our two solutions. Okay, this is the end of this lesson.